Some of you had some troubles on these problems here, so I want to make sure we get all these. So number 1a, we were supposed to put 0 into f, and f of x is 5 times 3 to the negative x power. So f of 0 would be 5 times 3 to the negative 0, and anything to the 0 power is 1, so this is 5 times 1, which is 5. So f of 0 is 5, so now we got to find g of 5. And that would be 3 times minus 5 times x, which we're putting in 5. So we got 3 minus 25, which is negative 22. Next, we're supposed to put f of x into g. So f of x is 5 times 3 to the negative x, and so we're supposed to put that into g. So we're going to replace the x in g with this. So the x in g is 3 minus 5x, and so in the place of the x we put 5 times 3 to the negative x. Now you can leave it like this. You can multiply the negative 5 times the 5, but many of you tried multiplying the 5 times the 3. And the 3 is to an exponent, and we can't calculate that, but exponents have to come before multiplication, so you cannot take the 5 times the 3 because you have to do the exponent first. And since it's a variable, that can't be done. You can do 3 minus 25 times 3 to the negative x, and a few people did 3 minus 25, but the 25 is times something, which we can't do because it's got a variable in it. So we don't do the subtraction because the multiplication has to come before the subtraction in PEMDAS. So this is as far as you can go. It would have been fine to leave it like this, but that's as far as you can go with it. H inverse. So H is the ordered pairs, and so we're swapping the x with the y to get the inverse. So it's going to be 2, 1, negative 11, 2, because it was 2, 11. The 4, 2 becomes 2, 4. And the negative 1, 5 becomes 5, negative 1. D. Now we're supposed to find G inverse. So first you change the G to a Y. Y equals 3 minus 5x. Change all Y's to X's and all X's to Y's. Solve for Y. And so this is kind of added or subtracted here, so we've got to take away 3 to get the 3 off of this side. So we've got to take away 3, not divide by 3. So we get x minus 3 equals negative 5y. This is times the y, so we divide by negative 5. And so we get x minus 3 divided by negative 5. And there's some things you can do with the minus sign, but this is fine. That would be what y is. Now you have to write it as G inverse. So we write G inverse of x is going to be x minus 3 over negative 5. Or if you will, you can multiply numerator and denominator by negative and get negative x plus 3 over 5, or you could put the 5 into each of these and you could say it's negative 1/5 x plus 3/5. but you should give me the final answer, what g of x inverse is. Next, we were supposed to put something into h and then take that and put it into g. So we're going to, these you always put down what you're starting with. The only things we can put in for into h are 1, 2, 4, and minus 1. So I'm going to start with putting in 1, and then I'm also going to start with putting in the 2, and I'm going to start with putting in the 4, and I'm going to start with putting in the minus 1, and I got to find out what eventually comes out of this. So now we have to putting 1 into that comes out to be a 2. The 2 turns out to be a negative 11, and the 4 comes out a 2. I'm writing these because I'm going to shove the paper up and you can't see. And the 1 minus 1 comes out to be a 5. And then I'm supposed to put those answers, the 2, into G. Now G, just to help you remember here, was 3 minus 5 times the x. And we're putting in a 2, so 5 times 2 is 10. 3 minus 10 is negative 7. We started with a 1, h changed it to a 2, and g changes a 2 to a negative 7. If we start with a 2, h changes it to a negative 11, and 3 minus 5 times a minus 11 is positive 55, and a 3 is 58. We start with a 4, it gets changed to a 2, and a 2 changes to a negative 7 again. And then we start with negative 1, it goes to a 5, and 5 changes to, as we found out up here, a negative 22. Excuse me. Okay. Now we're supposed to graph f of x, which is 5 times 3 to the negative x. So exponentials like this either go up or come down with it's a positive. So I'm going to put my x-axis down low so I got some room to work with. Put the y-axis somewhere in the middle here. And put some units on this. 1, 2, 3. I'll put 4 there. 1, 2, 3, 4 is on this line. So now I know what the spacings are. Now if I put in 0, 3 to the 0 we found out was, and then times 5 was 5. So at 0 it's at 5. At 1, 3 to the negative 1 is 1/3. So 5 times 1/3 is 5/3, or 1 2/3. And if I put in 2, I get 1/9. So 5 times 1/9 is 5/9, or 0.55, a little more than a half. If I put in minus 1, I get 3 to the 1, which is 3 times 5 is 15. So that's way up there. And it's coming down. And then it gets closer and closer to the x-axis. Now, since this passes the horizontal line test and the vertical line test, it's 1 to 1. And finally, find f inverse. So here was f, so we put a y in there. And then we change y's to x's and x's to y's and solve for y. So to undo this, we have to, since this 5 is times this, we have to divide. We can't multiply that because it's got a variable for the exponent. So we divide by 5, not subtract 5. So we get x divided by 5 is 3 to the negative y. And to now get the power down, we have to write this as a log. The base is 3. The base of the power is 3. So we write log base 3 of x over 5 equals negative y. Then we multiply by negative 1. We get y equals negative log base 3 of x over 5. A few people put the negative 1 up, which would flip this to be 5 over x, but you don't have to do that. Now we write it as the inverse. So f inverse of x is the negative of log base 3 x over 5. Now if you wanted to graph that in the calculator to see it, you would type in negative log base, say 10 of this divided by log base 3. Okay, number 2a. Several ways to look at this. We can write negative 3 log base 2. 1/8 is 1 over 2 to the third. It's one way to look at this, which means it's minus 3 log base 2 of 2 to the negative 3. That's the same as 1 over 2 to the third. The minus 3 could come down, and we'd have minus 3 times minus 3 is 9 log 2 of 2. So to what power do we take 2 to get 2? That would be 1 times 9, which is 9. One way to do this problem. Another way to do this problem would be to take the minus 3 up. And so we'd have log 2 of 1/8 to the minus 3, which is log base 2 of 1. The minus would turn this into 8, and the third would take it 8 times 8 times 8 is 512. And 512 is 2 to the 9th makes 512. Anyway, 9 is the answer. There's a couple ways to do that one. There are other ways to do this one. This one, 10 to the power of log base 10 of pi. This and these are inverse operations. They cancel and they leave us with pi. ln of e to the 2 square root of 3. This says to what power to take e to get this, or we could say move this down, so we get 2 square root of 3 times ln of e. So to what power to take e to get e? That would be 1. So we have 1 times this was 2 square root of 3. That's page 1. Page 2. Now some people got confused. 9 is 3 squared, and that's to the 2x plus 1. 27 is not 9 squared. It's not 3, it's 3 to the third. 3 times 3 is 9 times 3 is 27 to the 2x. So then if we rewrote this, this would be 3 to the 4x plus 2, because you multiply the powers when you have it like this. So 2 times the 2x plus 1 is 4x plus 2 equals, and here we multiply, so we get 3 to the 6x. So now we have single bases that are the same, so the powers must equal. So we got 4x plus 2 equals 6x. If you subtract 4x from both sides, we get 2 equals 2x, and x equals 1. When the variable's in here, and some people got confused by this here, it says log, and it's got a root 5 with the 3 in here, which means cube root to 6. So if we want to know this, this says, to what power do we take this, x equals 6. So it says, to what power do we take this to get x? This to the 6 is x. So writing this as a power equation, we get the cube root of 5 to the 6th power is x. But the cube root is 5 to the 1/3 to the 6th. And 1/3, when you got to a power, you multiply. So 1/3 of 6 is 2. Okay? Then we have this one. So they're all log base 10, so we don't have to do any base changes. But if we can get it down to a single log on each side, and this side already is log of 5x plus 2, and a single log base 10 on this side, then we can drop the logs and leave what's equal to each other. We just have to check our answer. So the 2 would go up as a power, so we'd have log x squared plus log 3. Now a lot of people just tried to drop logs there. Can't do it until you get a single log and a single log. So we have to do one more step here before we can drop the logs. When you add logs, you multiply. So it's log of 3 times x squared. Not 3x squared plus 3, which a lot of you did. Now we can drop the logs because it's a single log, same base, same base. So 5x plus 2 equals 3x squared. So this is a quadratic, so we're going to write 0 equals 3x squared minus 5x minus 2. Now you can put that into the quadratic formula, but you can also factor this. So we get 0 equals 3x and x. And if we put 2 here, we'd have 2x, and over 3 over here, 5 if we added, but it says subtract them. That's what the negative, one's positive, one's negative. So we better put the 2 here, so when we multiply, that's 6x, make it minus 6x, and put a 1 here, because minus 2 times 1 is minus 2, we get plus 1, and that would make this. So setting these two equal to 0, we get 3x plus 1 equals 0, subtract 1, 3x equals negative 1, dividing by 3, x equals negative 1/3 is a possible answer. Setting the other one at equal to 0, x minus 2 equal to 0 means x equals 2. Another possible answer. Now if we look at this and say, if we put in a positive 2, this would be positive, that would be positive, so that should work. If we put a negative 1/3 in, the argument here would not be positive, so that one can't work. And you can go ahead and plug in 2 in here and get to see that'd be 10, 12, log of 12. And this side would be log of 12 if you worked it all out, or you can work out the decimals on that. The 2 does work, so there's our only answer on that one. The next one, this has got an exponent, so you can't multiply it, so we have so let's change it all the bases now. Most of you changed to base 10. So 5 can be rewritten as 10 to the log base 5. 10 to the power log 5. 3 can be written as 10 to the log of 3. And that one is to the x plus 1. And 7 is 10 to the log 7. And that's to the negative x. Now, some of you did some fun things here algebraically. I'm just going to go straight forward. So we're going to have 10 to the log 5, 10 to the log 3 times x is x log 3, and log 3 times 1 is plus log 3 equals 10 to the negative x log 7. Now, when I multiply, I add the power. So I'm going to have 10 to a very long power here. We're going to have log 5 plus x log 3 plus log 3 equals 10 to the negative x log 7. Now I have a singleton base and a singleton base, so I now can set the powers equal. So I'm going to have log of 5 plus x log 3 plus log 3 equals negative x log 7. Now I should get all of my x's on the same side. And so a lot of you subtracted x log 3 from both sides, and that's the correct thing to do, but then you made a mistake after that. So they wrote log 5 plus log 3, and since it was added, a lot of you wrote it as log of 5 times 3. Sum becomes a product. That was great. And this is negative x log 7 minus x log 3. And some of you, this is where several of you got messed up. So we got log of 5 times 3 is 15 equals, and some of you factored out the x and then just said, oh, they're subtracted, so divide. But no. I would factor out a negative x, but if you don't factor out the x, then it's negative log, if you don't factor out the negative, it's negative log 7 minus log 3. So they're both minus. Think of this as minus of log 7 plus log 3. You really should have factored out the minus. And so now the 7 is times the 3. So we get log 15 equals, I'm going to put the negative on the x. You could also put that, leave it in there, but I'm going to write negative x times log 21. So now I need to divide by the log of 21. And so I get negative x equals log 15 divided by log 21. And then multiply both sides by a negative, and I get this as my answer. Okay. Not quite so lengthy a problem. This is probably the toughest one on the test. This one was pretty straightforward. We have subtraction of logs, so it becomes the log, base 10, of x plus 21. When you subtract, it changes to division, equals 2. This is log, no base shown, so it's 10. So now to solve this, we're going to write this as a power equation. 10 to the 2 is x plus 21 over x. 10 to the 2 is 100, and if we multiply both sides by x, that gets rid of the x, and it doesn't take it in times here. So we get 100x equals x plus 21. Subtract x, we get 99x equals 21. Divide by 99, and we get x equals 21 over 99. If you divide 3 into that, you get 7 over 33. And that's a positive number. That works in there, and that works in there. So we check our answer, and it does check. Okay? And now the final page. All right. So the formula for this decay is this. This does not say A of t. It says the amount after some time t. And it says if determine K if you start with 10 grams, so that goes in for the starting amount. So, and ends up as 2 grams. So that's the ending amount. A of t is the ending amount. 2 grams equals the 10 grams you started with, e to the k times however long, and they said 30 days. So t is going to be in days. So to solve this, we divide by 10 on both sides. And this is 0.2, so we get 0.2 equals e to the 30k, and remembering the 30s in days. So now we need to solve for a power, so we change it to a log. So we have the base is e, so we go ln, and so e to the 30k is 0.2. E to this is this. Now to solve for k, we divide by 30. And we get k to be ln 0.2 divided by 30. K is negative 0.0536. All right. How much of the 10 grams is still radioactive after 10 days? So the amount left is what we're trying to find, and it's going to be equal to 10 e to the k. The k, we're talking about the same radioactive stuff, so the k is the same, so we're going to use negative 0.0536 times 10. So that's just type it into the calculator. So we're going to go second, 10 second e to the x, and the power is going to be negative, and I should put this in parentheses. This calculator does it automatically, but I'm going to put the parentheses for those of you not doing it. Negative 0.0536 0.36 times 10, close parenthesis, and I get 5.85 grams. Are still going to be radioactive after 10 days. And that makes sense. If it was 10 to start with, and after 30 days it's 2, after 10 days it's going to be somewhere in between, which is what this is. Now C, how many days will be 30%? Well, 30% is 0.3. So looking at this formula, if we want 30% of whatever we started with, just this has to be 30% or 0.3. 0.3 is 30%, not 1/3, 30%. So 0.3 is what e to the k t has to equal to get 30% of the starting amount, 10. And if you wanted to put over here, 30% would be 3. You could put 3 equals 10 e to this power and then work this out. Put 3 here and leave a t there. But this is, when you divide 10 into the 3, you get 0.3. So that's how you get the 0.3, or the 30%. You need to solve this, so we write this as a log, and so we get ln of 0.3 equals negative 0.0536 t. So you divide by this. And we get t to be not that. Negative 0.0536. Then we get 22.5. 22.5 days. Okay. And D, what's the half-life? So that means that whatever this is, we have to be able to multiply by 0.5 to get half. So if I put 5 here, then I put 10. But if I want to just talk about this, I say 0.5, meaning half, is what we're multiplying by. The e to the minus 0.50536t has to be 0.5. This looks exactly like this one, except 0.5 is now 0.3 is now 0.5. So the answer is going to be ln 0.5 divided by negative 0.0536. So I can just take out my calculator and go second enter and change the 0.3 to 0.5 and get an answer of 12.9 days. Okay, last problem. And several of you went to did continuously compounded. Several of you didn't know what to put in for n for quarterly. Quarterly means every 3 months, 4 times a year. N is how many times a year. So n is 4. Interest rate, 3.75, but you do that in decimal, 0.0375. So, starting amount goes into A0. The amount after some time later is going to be 2,000. 1 plus 0.0375, 0.0375 divided by 4 for 4 times a year to the 4 times the number of years. These match, and it's how many times in a year. So they want us to figure this out after 10 years, so I put 10 in for the y and work this out. Now to type that into my calculator, I'm going to go 2,000. That's in a bad spot there. Let's put it over here. 2,000 parenthesis 1 plus 0.0375 divided by 4 to the, I'll put a parenthesis, 4 times 10. 4 times a year times 10 years. And I get the amount after 10 years is equal to 2904.90. Okay. Now, how long will it take for the balance to be 5,000? So that's the amount after some time. So I got to write 5,000 equals 2,000. All of this 0.0375 divided by 4 to the 4 times the number of years. Well, to do this, we're going to have to divide by the 2,000. 5,000 divided by 2,000 is 2.5. So now I got something to a power, and we got to solve for the power. So we're going to write this as a log. To what power do I take? And so my base is all of this. So down here in the base is 1 plus 0.0375 over 4 of 2.5 equals 4y. Now when I have to do this on a calculator, this becomes the log of the argument in base 10 or base e over the log of this base, which is 1 plus 0.0375 over 4. And that's what's going to equal 4y. So I'm going to have to take the answer and divide it by 4. So let's figure out that number. So I'm going to type in log of 2.5, close parentheses, divided by log of 1 plus 0.0375 divided by 4. So I get 98.195. That's 4y, so I have to divide that by 4. So if I divide by 4, I get y equals 24.5 years. And the last one, how long for the balance to double? So that means if I start with 2,000, this needs to be 4,000. Or the number I'm multiplying has to be 2. 2 times this would be double. So I can just work with that and say 2 has to equal 1 plus 0.0375 over 4 to the 4y. So once again, I'm going to get the log of 2 over the log of this, like I did before, only it was 2.5. So I'm going to go back here and just change this to 2. And that's 74 is 4y. That's what the 4y will equal. So 4y, let's write this out. So this would be a log of 2 base 1 plus 0.3703, 0.0375 over 4 equals 4y. And so I do the log of 2 over the log of that, which is what I did here. And so that's what 4y is, 75.28. And then I have to divide that by 4. And I get 18.6 years.